Good evening to everybody all over the world. My name is Timothy. This is our third day. Today is Thursday, April 18, 2025. This is our third day. And this third day, I would like us to continue from where we stopped about 2 days ago. According to our timetable, we said we're going to have a class between Monday, Tuesday. We skip Wednesday to relax, and we have Thursday, Friday. No lecture on weekends. The weekend will be used for practice of whatever we have been taught during the week. So please, this area of machine learning our tutor is taking is just an additional knowledge to us. It's not our target objective for the training. Our target is on deep learning. Deep learning. And if you tell us what deep learning is all about, we will get to that stage. So I'm sure between today and tomorrow is going to buckle up to finish the area of machine learning in the car. Over to you, Ayobami Salau. That's our tutor tonight. Please take over. Thank you.
Okay, sir. Thank you, sir. Yes, sir. Good evening, everyone. You are welcome. So we are going to continue from where we stopped Tuesday. So, and I would like to share my screen right now, so we can see what I'm about to do. So, I want to ask a question. Have we tried as much as possible to go through the available materials that were sent on the group?
Please,
Have we
I would like
been?
you, Ayobami, I would like
Yes,
you
sir.
to make sure that the when you are sharing your screen, is there any way you can probably minimize appearance of people on your screen so as to enlarge the one you are sharing? Because there was a feedback I received about with that is there any way you can just minimize the images of people around your computer so that we can see clearly, boldly
Yes,
what you
yes,
are
he can do that.
uh,
Those three dots you are seeing below,
okay.
those three dots, when you click on those three dots, you will see full screen.
Okay.
Full screen. Yes,
Okay,
yes.
good. One can see full screen. So that means when you are sharing, okay, good. Thank you very much. That's it. I don't have to with me here too. So you can do yourself too. Please share your screen and let us see.
I'm going to share my screen now.
Okay.
Just a minute. Okay, I think we can all see my screen right now.
Yeah, we can see your screen, but I would like you to use that double point so that you can go away from you can go away from use that three dots so that you can see your screen in full.
I think he has done it. He has
It's
done it.
not. Okay, I think we stopped at. Okay. Oh, sorry. I'm not talking about deep learning yet. So let me go to this. Talking about something else. Sorry. So I want to open the notebook that we were using on Tuesday. So we'll continue from there. So while that is loading, I don't know if we're able to go through this. So because we're talking about this part, so we talked about the data set itself. So we looked at the data set and we saw that there were some missing values, which is NaN not a number, which we
So
indicated.
for participants also, if you want to enlarge your screen, please do the same.
So, and we also talked about, okay, the feature selection. Yeah, we looked at the numerical columns, which are the summary statistics. This is the data set description. So we looked at the passenger ID, survived, passenger class, age, siblings and spouse, parent and children, and fare. So we looked at the summary statistics here in the last class. And also we looked at the data set summary. So we saw this in the code that not all the data for some particular column is complete. For example, survived, yeah, it only has complete 891 rows. So, and while the rest is missing. The same thing for cabin, same thing for age, just needed some things to complete. So, and we look at the correlation value. So, and we saw that there is a reason why the correlation values between some variables are not that strong, and it's because of the missing values that we have in the data set, which is being shown in the data set summary. So, and we went into visual data exploration, and we talked about the correlation matrix, which we saw, and we looked at this, and we saw that the values are just too small. So it's not something that is very appreciable because of the missing values that we still have.
Excuse me,
So
sir. Excuse
yes,
me,
sir.
sir. Sorry for the interruption. I just want to confirm, sir. Mr. Timothy, is the class currently being recorded?
Exactly. Exactly. The class is being recorded.
Okay, sir. Okay, sir. Thank you, sir. You may proceed, sir.
Okay. So and we looked at this. We look at the survived passengers. So visually, we saw the number of count of people that did not survive and the people that survived. So we saw this year that 38% of passengers within the training set survived when the Titanic sank, and it equates to 342 passengers out of the 891 in total. So, and we saw this. This was where we stopped. I think yes. So, and which we looked also at the passenger class, looking at it from the point of view of those that survived. So, although we have three levels, which is the upper, we have the middle, and the lower. So, and we saw that those that did not survive are really more when compared to the rest of the two classes, which is the upper and the middle, which is seen here in the plot. Yeah, and we looked at this in terms of the percentage of survivor. So, and we saw that the percentage of survivor, when we look at it in terms of the three classes, ticket classes, we saw that the upper has even more percentage when compared to the middle class and the lower class, which we saw. And the code to do the plotting is actually inside the Jupyter notebook. So I'm going to check this now. Okay, I think we have that's come up, so I can open the Jupyter notebook. Sorry, my system is a bit timing. Okay, it's coming up. Okay, this is it. Okay, so it's loading right now. Okay, This was where we stopped. So now we are going to continue from this point. So I want to look at the H. Now, what we want to do is that we want to create a bar chart of age that is mapped against the sex.
Is that where we stopped? Show love. Can
Sir?
you see? Is that where we stopped?
Yes, yes,
Yes, that was where we
yes.
stopped. Exactly. So this is what the plot looks like. But what we want to do is that create a bar chart of age that is mapped against sex. So for now, the missing values have been dropped and will be dealt with later, like I said. So we just drop it and we will deal with it later, but we are not looking at it for now. So now what we want to do is this is that now we want to create a variable here. This is a variable says survived is equals to survive. So this is a string, not survived is equals to not survived. So now we now set a figure and axis. So we say plt.subplot, and the number of rows should be one, and number of columns should be two. So that's why we have the number of rows. This is one row and two column. So we want to create two column where we want to map the age and sex. So where we have female on one of the column and the male on one of the column, which is being set here to two columns, as you can see here. So, and we said the figure size should be 10 by 4. So the dimension be 10 by 4. So now we also see we have women is equals to train, and we now say that's we are picking from the train data set here. We now say train, then from the train data set, we said it should pick the colon, which is sex. So from this our colon here, which we are going to see from here, which is this. So it's picking this colon, which is sex. Yeah. So now while picking that, we now said that we set it that this variable, anytime it goes, we look at the train set, it should always pick the variable that is female, that's equal to this. The same thing we did for men as well. So it picks the colon, which is the sex, which is this. So and it picks the male. So we set it to male. So now we now created the axis. Now says equals to that is SNS dot distance plot women. So which means that the women a variable that is being created here by picking the sex column in the train data set. So, and from this, you should pick the survived, that if it is survived, then it should be equals to 1. Then we should, that dot age dot drop. So what we are trying to do here is this is that, like we said, we want to drop the missing values. So this will help us drop the missing values. So now if the columns where we have females that's under this, let me just explain so you get what I'm saying. So for example, now under the survived, yeah, there are still some missing values. If you look at this place, survived is not up to 1,309, which is the complete rows. So there are some that are missing. So, and we don't want to use the ones that are actually, let me put it this way, that are missing. So anytime we want to pick anything from the sex colon, yeah, which is this, and if the corresponding colon for the sex, for example, let me put it this way. Let's say that this particular, let's say this particular row, this is sex female, and this particular place is empty. It is none, not a number. Then it will not use it. So it will just drop this particular row. It won't use it. So that's the work of this here. This doing this. So we are setting it that if it doesn't have anything that correlates with any number on the survived row, then you should drop it automatically. So and the same thing we did for men as well. So we now say that as well, which is here. And we said female. And when we plot, we have the divide. So when we compare the count, this is the count here. When we compare the count for female, for each age, those that survived. So you can see the comparison here that the those that survived for the female uh, than those that did not survive. You can see that are men on the large. So now we can see here that more can be understood about age when plotted alongside the sex, like I explained. So this graph reveals that overall women were much more likely to survive than men, and this is largely regardless of age for both sexes. So it appears that chances of survival are more likely at a younger age, which is what might have been expected from the age of 20, which you can see here. So we can see this. And it was consistently more likely that men would not have survived up until their age approached 80, like is here. So now for women, apart from a potentially anomalous finding around the 8 to 9 bracket, they were always more likely to survive. That's from the 8 to 9, which is this anomaly here. So, and we can see that normally, obviously, from the visualization, women are likely to survive more than men. So, like we see from this plot here. So, another thing here we did was to compare parent and children. So, here we are trying to plot survival rates versus siblings or spouse on board. So, this is what we did. Yeah, this was the way the plot looked like. Not sibling or spouse. Look at those that don't have siblings or spouse at all. Number of siblings or spouse, if it is 0, then they were likely to, if it is no, which means that they did not survive. So here we see that yes, they survived. So now this from this plot here, we're looking at the survival rate with total of siblings and spouse on board. We can see that those that have as the number of siblings and spouse increases, then we can see that the the survival is actually okay, like from what we are seeing here, and the rate of not surviving is even higher for this. But from the explanation here, the structure of the two graphs appears similar, just this way. It's just like it's going down like this, and the one for the survival rate with total parents and children on board as well. So it goes down this way. So with no children at all, yeah, then we can see that they actually survived very well, and there are also those that did not survive are much. So, but as the number of parents increases, so we can see that the survivor also decreases as well. But depending on the number of the parents or the children, actually. So now, um, this adds further rationale for these two features to be combined. That is, and the survival rates of total siblings and spouse on board, and survival rate with total parents and children on board. So, which will be performed at the data preprocessing stage. So, this is something, a feature that will be needed because it actually explains a lot. That okay, the more number of siblings and spouse, or the higher the number of parents and children, then we can say that we have fair numbers of people that will survive and those that will not survive compared to when not having siblings or uh, siblings and spouse, author and parents and children, which is shown here. So now this graph here, we are seeing a graph here for fare. So the graph, this graph here to display fare paid per the three ticket type. So it's just the number, the amount of money that was paid per the three ticket types. So and what we did was we used a swarm plot. This is what I call a swarm plot. Yes. So and we set the figure to by using um, matplotlib. So and the set PLT of figure set figure size to 10 by 5. I will now use SNS. Set the SNS the swarm plot. Now set x is equals to the p class and y is equals to the fare. So and data is equals to train. So what we did here was that we tried to use the train data set, which contains every of the features we have. Then from the train data set, we set the passengers class, the P class, to x-axis, which is this, and we can see, which you have three levels, which is one to the upper, the middle, and the lower. So and also we have the fare, which is on the y-axis, which is being picked from the feature inside the train data set. So which we have on the y-axis. So and what we now did was this was that we used the EU. Now the EU that we used was which is still a feature in the train data set survived. So now what we want to see is that we want to compare the fare and the passenger class. So now what we are seeing here is that zero means not survived, one means survived. So if we look at this plot here, fare has been displayed per ticket type, revealing that those within P class 3 they paid a similar fare passenger class, that's P class 2, but their chance of survival appears to be a lot lower because if you look at this here, there is the blue dots are actually more here when compared to this year. So, but P class contains the highest fares. So, along with the highest rate of survival, which is denoted by the higher ratio of orange points. So, as we see here, that the orange point denotes the survivor, that the highest rate of survivor. So, and we can see that for the P class 1, which is seen here at the upper class. So now this shows that those that are likely more to survive per fare paid for each class is the P class 1, as seen in this plot here. So now we want to move into future engineering.
Before you move to that,
So now,
you have less than 5 minutes for this class to end. So I'm going to give out another link now, which in our WhatsApp group so as to join again.
okay,
I spent almost 20 to 30 minutes before you arrive at that time. So probably you can be explaining the future engineering, but at the same time, the time we will chip in under link, so we can continue from there. So continue now.
okay. So now, like I said, when we started the training, I said feature engineering is the vital aspect of machine learning. That how good someone is in feature engineering will determine how the model will be uh, very good and if the model will perform very well. So with a clearer understanding about the current data shape, so which we see that it is 1309 by 11 or 12. As you can see, we can now start engineering features so they are ready for modeling. So some steps will be things we need to do. For example, filling in blanks, which is the blank spaces like NaN, not a number. So another steps are more choice in terms of making features more useful. For example, those features that have combinations that just have words that we can change to numbers, then we will do that, thus allowing for stronger model performance. So I'll begin with one such feature, and that is the family survivor. So now the aim of this feature is to group together people, usually families with similar ticket information, with the logic that groups that are together have similar survival chances. So I encourage you to follow the link to learn more about this feature as the code is quite complex. But in my opinion, it seemed an interesting and logical feature to create. So I'm adding it in my data set. So that this is the code actually. Yeah. So the family information. So um, what we did here was to try as much as possible to create an information for family survivor to create a group. So that's what we did. So we are trying to extract last name. Then we also fill in missing fair value by overall fair name. So what we did here was this was the missing values in the fair. Look at this place. We have fair here. There's there's only one missing value that we have in fair. So and we just want to replace it. So we said data fair dot fill now. So if you want to fill a missing value, so we use the dot fill now. Then you now specify the data you want to try and fill, and you specify the colon. Then you now say now you should take the mean of that colon of this colon, which is the fair, and replace it so with the empty spaces. So anywhere it sees any empty space in this column, which is the fair column, it replaces it with the mean value for the fair. And that mean value, which is actually this value, replaces it with this value. So that is replace it with, which will complete the make it complete on 309. So that's about that. And also setting coin flip, that is the random chance of surviving. So that what we did was that we created a variable which default chance is 0.5. So which means that it is not certain that someone will actually survive. So it's a 50-50 chance. Just like the person survive or the person does not survive. So it's just like we're introducing here. So we now said data should be family survivor is equal default survival chance. So the family survival now will be 0.5. We are setting it to be equal to this. So now we're now grouping the data by the last name and fair and looking for families. So from here, what we did was we extract the last name. So here now, what is that if we are, we have some families on board. So we are trying to by their last name. So because not everything is together the way it is. So we group data by the last name and the fair. So what we did was this was actually for the group itself, then a group underscore data frame in data. So we now said survived, name, last name, ticket, passenger ID, siblings and spouse, patch, age, and cabin. Mind you, this if you look at this, we already have this already here, which is the name. And if you look at this, name is already here as well. And if you look at fair, already here as well. And if you look at already have tickets too as well. We have passenger ID, which is here, and we have siblings and spouse and children. We have age, and we have cabin. But the only thing that is not there is the last name. So, and the last name is was created. So we just added this variable, which is last name. We created another variable, which is last name, and that is from the same variable, which is name, which is which is here. So, and what we did here was that we only last name. So, like for example, if we have anyone bearing Aris, so to look through the colon and look for last name, anyone that has a name Aris, so then it's going to split it, then and it's going create a colon and put it and create it. That's last. So now with everything and everything, just we have simple flow statements if for if elif. So which yeah. So we now said if not equal to one, a family is found. So then what chance depending on whether or not that the family member survived. So with this code written here, now the number of passengers with family survivor information is 420 out of the 809. So that's the number of passengers with family survivor information. That's we have information because it's not everybody that is accounted for. So, but those that were accounted for based on this code that is written here. So, 120 people you can see. So, and I talked about this already that based on what we did here, we created a variable, new variable which is last name, and we're able to group families in such a way that the number of passengers with family survivor informations are 420. So we're able to get this. So and we also have if not group information. We said if not equal to one, survival chance depends on whether survived. So now what we want to do here is this: is that we know that we set our survival default survival chance to be 0.5. So and normally if it is equal to 0, so we know that means not survived, and if it is 1, that means that it means that they survived. So but here it said that if not equal to 1, a group member is found. So that's for those that did not survive. So now what we did was this statement, yeah, and we were able to do that, grouping it by the ticket. Yeah, we have by ticket, and for the if the family survivor is equals to 0, and we compare it also with family survivor when it is equals to 0.5. Then we were able to now come to the conclusion that it should be able to, with everything, we're able to print number of passengers with family or group survivor information. Yeah. So and we say number of passengers with family or group survivor information is 546. So now the thing there is that for this feature to work, the train or test index had to be kept as it is. So for the remaining feature engineering steps, this isn't essential. So I will reset the index. So we now have one continual index that is 1 to 1,309. Than 1 to end of the train set, which is followed by 1 to end of the 2 years. That's why we have one up to 1,308. But if we count that 0 and we count it together with this, we have it together to be 1,309. So
Ah,
now The thing there is that the index runs from 1 to 1,309. So which means that it is complete normally. So this is the index here. So it has 1,309 rows. So now we want to progress further. Now I want to work on fair. So the single missing value, fair value was taken care of previously. If you remember, where we use the fill.na, which is this, we use this, we filled it with the mean of that column, like I explained. So, and if you look at this here now, the single, okay, so let's take a look at fair overall and see whether we could or should take any further action. Now, we are trying to look at visualizing fair data. What we see is this histogram distribution. You can see the way it looks. So that is a fair from ideal view. So there's quite a severe left side skew. So this is left skewed, which probably won't pair up all all that well with machine learning algorithms. Because normally, if you are to use this, it should be at least a bit should be normally distributed. So that's the ideal way it should be. So I think there's two possible approaches here. So it's either we turn fair into a categorical data by breaking it down into bins, or number two, we transform the data so it fits in with a normal distribution, like I said. So because we can't use something that is so left skewed like this and something that is so right skewed goes this way also. So it's going to really affect the performance of the predictive model I'm trying to build. So, like, there are two suggestions here, and basically, this is what most people always actually do most of the time. So, when you are trying to use a feature and you see that feature is very important to contribute immensely to the algorithm you're trying to build, so all you just need to do is try as much as possible to first look at it if it is left skewed, right skewed, or normally distributed or bimodal. So then you can actually find something to do about it. So we said the first one is turn fair into a categorical data by breaking it down into bins, or transform the data so it fits in with a normal distribution. So what I did is that I played around with both options. So in the end, deciding on using bins was the most effective means of proceeding. I also achieved a better final score using the bin approach. So now to create my bins, I'm going to use the Clever Pandas Q Cut tool. So which creates equal size bins based on the quantity chosen. In this case, four. So four uh, bins. Yeah. So now, like I said, yeah, if we are looking at this thing this way, I said most of the time for newbies, basically, this works very well. It works, but the use, because this is what later results into, but it depends on what you want actually. So, and how good you are. So, but it's still anyone that you want to do will also work, but it's the first one we are going for. So now, want to turn fair into four bins due to the heavy skew in the data. You can see that there's a heavy skew here, which is not ideal for the model we are trying to build. If we are going to use this feature actually. So what we are going to try to do is we now pick, when we imported our data, the train data is we call it data. So we pick this column, which is fair, and which is this fair. We picked it from our data. We now use the Q cut. So we said pd.qcut data fair, and we share it into four bin. So that's what we did. So now I will now use the label encoder to convert the bin ranges into numbers. So now I created a variable which is label encoder LBL, and I said is equals to label encoder. And I said data and the fair is equals to the variable created here, which is the label encoder function. Yeah, so we said label dot fit underscore transform the data. You can see fair. So what we did here was that we are trying to use the label encoder on this um, feature here in order to take care of the skew, heavy left skew that we have here, as seen in this plot. So we want to visualize the new look.
Hello, please excuse me. Can we be asking questions while the lecture is going on, or we wait till the end?
Oh, you can ask your question even if it is
Let's
not
wait till
clear.
the end. No, let's wait till the end. Give time to ask questions. We'll still
Okay.
show love even if it's early. Give you time to ask questions. So let him finish.
All right.
So we
So
explain the lab.
you can be
Let
noting
him explain there
the
close to any lab.
question.
Any lab board you want to ask questions, then go there. We'll explain to you again.
All right. Thank you.
Please continue. Yes. Thank you.
So now we use the label encoder, and what we did was this: we created four bin actually. So and you look at this, yeah. What we have was just this now, but now changing the entire view into something of this nature. So what we did was we changed everything. So we now visualize the new look for the fair variable, which is a feature in the data set that we have, this data set. So say sns.count plot data fair, then we set the x label to be fair bin, y label to be count, just we are seeing here, and the title should be fair bin, and we run it, and this was what it gave us. Yeah. So now setting this, now you can see that it looks much more different from the way this looks like. Yeah, just like we have. So now basically this can actually with this new look and using the label encoder on it, then we can use it in our predictive model, which depending on the algorithm I want to choose. So now we also looked at name. We are doing feature engineering now, name. So now once we're inspecting the first five rows of name, now what we did was is we said the train data set, the name, just show only the head. So and the head, like I said, is just to return back the first five rows. And this was what it did here. If you look at this, the full names as they are will not be helpful to us, obviously. Although there is probably something useful within title, e.g., categorizing males and females, boys and girls. Therefore, I'm going to extract this data and create a new feature for title before pinning the name. So now when we say title, for example, now if we want to know, we know there are some titles we have Mr., we have Mrs., we have can have sister or brother. So now Mr. can be for someone that is mature, so or someone that is married. So a brother or a sister can be for some those ones that are not married. So that's just depending. So now the function, I created a new function to return name title only. That's the title. And the title is here. If you look at this, we have Mr. You look here, we have Miss. You look here, we have Mrs. You look here, we have Mr. So now that's what we are interested in actually. So now we now define a function. We said define this is a function. We said we define a function and the function name is get title as a function name. So and the variable we are considering here is a name, actually name. So we now said if we see anything of this nature in the name, then return the name dot split. That is name dot split as anywhere we have a comma. So and we are going to pick anything. Now this is the way it is. Now if you look at the positioning, there is always something came before. We have this. We have zero. You can see this zero. This is one. This is 2. So now, if you look at this is what we say return name dot split. So now, what is going to return is after this comma, we know that what we need the title and it should strip it, or else it should return unknown. So that's the function. And to use this function, there's a way we are going to use the function. So we are going to create two lists of titles, one for each data set, which is the train and the test. So we now say titles underscore data is equals to sorted a dummy variable, then data name, dot map it, and we use the lambda function, and for the dummy variable x, then get title x. So now in this case here, we are trying to say x in data. The x scans through the name, colon, and actually looks for whatever it is that is inside the command that we have put in here, which is the function we created here. So, and it's going to return whatever it is that we have said it should do, or else it will return unknown. So now, if you look at this to understand better what we are working with, the list size and values will be printed below. So we want to print list length and items in each list. So we say you should print the length of the title data and the titles data itself. The length is 18. So now that means those titles that are in that column actually in the name. So all the titles that we have there, but while using this function, so it was able to scan through and return captain, colonel, we have Don, we have Donald, we have Doctor, Junkia, Lady, Major, and so on and so forth, Reverend, and we have that. So we have 18 unique title values. So and it is a lot, and I anticipate that for many, only a few observations exist, which isn't helpful. So I'm going to keep this simple and band titles in one of 4 categories, which is just these categories, because this actually makes more sense and is common as at that time, which is Mr., Mrs., Master, and Miss. So to help me complete this, I will define another function again as well. So now another function, what this function is doing now is this is we are trying to use a control flow statement here now inside a function that we created. So this we said it should now set, we created a function, said define a function using the delf statement. So we have the delf keyword, we have set title, and we create a dummy variable x. So title is equals to is the title that have as that we created, which are all this. Then we have that if title in, and we have Captain, Colonel, Don, and so on and so forth. Then return Mr. Else if the title in the Countess, MME, Lady Donna, return Mrs. Else if title in MLLE, MS, return Miss. Elif title, that's else if title if it is doctor. And if the sex is male, you should return Mr. That is for anyone that has this title, doctor. And if it checks through the column for the sex, because we can have a male doctor and female doctor, so we'll not mix it up and give them the title that is not supposed to be given them. Either we don't want a situation where we have a female doctor and we now assign the title Mr. to the person. So we want to change all these people. Normally, all these people are by default are going to be Mr. So that's why we say you should return Mr. if it goes through the title and return. So the same thing for this here. We said anyone that had this should definitely be a Mrs. So return Mrs. Anyone that have anything like this should return Miss. So anyone that the sex of the person is male, then return Mr. Else you should return Mrs. So else you should return the title. So now after doing that, is a function, and the function name is called set title. So we now apply the get title function to create the new title feature. So we now say data title is equals to data, then the name. Now what is happening here is that we now map it using the lambda function. So we said get title x, which means that it's getting all the old title normally, all the old title in the name colon, which is this name colon that we have here. It's getting all those. And after getting it, then the data, also the title that we have, which is a feature, then we now apply this set title. So we don't need all this. So we just want Mr., Mrs., Miss, and like we said, and master. That's what we want the axis to one. So we now print it. Printing values of the title column, checking whether the function worked. So we print the data, we print the title, and dot value count. So this value count actually returns a unique values, the value for every of layers or levels that are there. So it returns this that for the Mr. we have 782, for the Miss 264, for the Mrs. 202, for the Master 61. So and the group sizing looks good enough. So, and I'm happy to continue with whatever I'm doing. So, with what we have here. So now, to continue what we are doing. So, age has some missing value here. So the age has some missing values. You can see from here. So, Returning NaN within age across train and test set is now is going to check if it's going to check through that particular column and count and look to use the below information to help decide on which might be most accurate. Now, what I want to do is that, what we did is we have changed all the title actually. So now, the new title feature, we want to use to calculate the missing age values now. So what we are doing is that we want to check if which statistics to use in the imputation to fill in the missing age. So now, when we want to do that, we are using the describe function. I want to describe particular variable or a feature in your data set. So you can use the dot describe and just only describe only that particular variable, just like this. So you just only pick the the variable by only picking the specifying it. So you specify data, then using square bracket, you pick that particular column. So then dot that's you specify the name dot describe. So now what we did was this: we said you should exclude um, anything that has the missing values there. So we just only exclude it. So and that's because if we don't exclude it, it won't return the actual value to definitely not give us what we want, or it's either it gives an error. So now it gives us the count. So the count is this: is that we have 1046 for the age. So that's the ones that have the values that are not missing. So now when it now took the mean, so this is the mean value, the standard deviation, you have the minimum, you have the fifth percentile, 50 percentile maximum as well. So the mean and percentile breakdown indicates multiple features converging around the 30 mark, and which perhaps isn't sub percentile. We have 28, you can see here. So it's converging at that value. So based on this, it may be better to proceed with imputing with the median, which is the middle value. So, and what I'm now going to do is group the data sets by the four different titles and then impute the missing age values with the average age of each title. So, and be that Mr., Mrs., Master, or Miss. So, what we want to do now is this: is that we know we have different layers of that is the title now, which is for Mr., Mrs., Master, or Miss. So, but across the board, for anyone that have Mr., and we know we have those that are under Mr., that have the title Mr. and they have missing values. So we'll just only we'll do it in such a way that we'll calculate the mean value for only the Mr. And when we get that value, we will now take that value and replace it, the missing values for the Misters that have missing age. So we'll replace it with that. So we'll do the same thing with Mrs., or Master, and the Miss as well. So that's what we'll do. So now this is what we want to do now. So imputing age within the train and test set with the median. So grouped by the P class and the title. So this is what we did here. So we said data, yeah, we pick the age. Now that's what we are working on. So it's because so we now group it by the title. So why did we group by the title? Is because of this. Yes, so because of what we're interested in. So and we should compare it by age actually. So then we now apply um, the lambda function in such a way that it will fill the the age with the median value for all the titles. So now, if we now visualize the new look for the age variable using a histogram plot, so we can see this here that the distribution of ages, which we are seeing here. So so now we have completed view of age. So it makes sense to visualize it, which is this way. And the distribution isn't bad, so but it is not satisfying. So a slight left skew can still be seen, which is here. You see it from the way I'm viewing it. So, and I'm going to follow the approach used for the fair feature by turning age into bin as well, which is what we did here because of the skewness, left skewness of fair, as been explained earlier on. So now this is what we did. So we are using four bins as well. So just the way we did for the fair. So we are using the label encoder, and we are going to now plot the new look. So this is the way it now looks, having a four bin for it. So we have it this way. So now I will stick with these bins for now. So now that I'm finished using the title feature, we round up this is the point there. Normally, the title will make sense. That is to be able to know, okay, who survived? When we have our model, who survived? Okay, what is the title of the person that survived? Is it a master, a Mrs., a Mister, or a Miss? So, but this is not useful actually in my model, but I have to turn it into something that will be useful, a number. So that's why I now did something there, which is data and the title. I want to change it. That's what I want to work on. And that's a data title. Replace all this, replace it with this value. So that means if I have 0, it's Mr., 1 is Miss, 2 is Mrs., and 3 is Master. So this is what we want to do. So we have sex as well. So are we following what I'm saying, please?
Yes, yes.
Okay.
It's being recorded.
We want to talk about the sex. So a simple step for this just recoding to numbers, machine learning usage as well. So this is just, I think some questions we have to choose to change some things into. So this is a practical example of that. We want to change whatever I want to change for numbers. For example, we have agree, strongly agree, disagree, neutral. So you can change it to numbers that is going to be used for machine learning. So this is something, a way to do that actually. So and you can do it for any layers of this thing. It can be um, anything at all, anything at all. It can be yes or no, anything I can think of. So the same thing we did for sex as well. So we changed it as well. And if it is male, zero, if it's female, one. So we code it into the value because that's what the machine learning algorithm understands numbers. So now we now look at embarked as well. So describing embarked. So we have the embark here, describe it, which is 4. Embarked is also here. So it has some missing value, which is just 2. So embark, the count is 1,307, unique 3. So this unique, what it means is that it has 3 levels or 3 layers, just like something like this, like Mr. Miss, but that's not it. But if you look at it, this is just it. S, C, and Q. So these are the unique um, identifier inside the embarked colon, like we see. So there are 2 missing values. So let's replace it with the most frequently occurring value, and we will then convert the letters to values, so which we will need. So and the top one is S, so which we see here. So that's what we are going to replace that one with. So in missing embarked values with the mode, which is the highest occurring, so which is S, using the describe function. So we have S, and then we now fill data embarked, fill now data the mode. So and that's what it did, and we are specifying so and the index. So we are now converting it to numerical value, and what we are trying to do is we are saying data embarked is equals to data embarked dot replace and change it to numerical values. So that's what it did here. There we have it. So now as well, um, the cabin. So look at the for the cabin. We are having issues with the cabin, having something of this nature. You can see have missing values. So now expecting the head of cabin colon, which you can hear. So upon closer inspection into cabin, we can see that it's for letter number format, which is this seen here. So a bit of extra internet research reveals that the letter refers to the floor in the Titanic where each passenger resided. So this information may be helpful in the prediction. For example, those in the lower cabins have a smaller or larger chance of survival. That's the question. Therefore, we'll begin by data only from the cabin column and then labeling all not in numbers with an unknown cabin reference to show that we don't know their cabin. So now this is so labeling all the not a number values as unknown. Said data cabin dot few now. So the few now unknown. So and in place is true, which means that this few now, what it does is any missing or not number is going to replace it with this particular um, name, and we are setting it to be true. And now extracting the first value in the each the cabin, and what we are trying to extract is we are trying to extract. Look at this here. This is what we're interested in. The C. What we're interested in here. The C. So just to show the the cabin reside, the passenger resides. So and to do that, we extract the first value in each row of cabin. So and how did we do that? We actually picked the cabin. We now used a map function whereby we are using the lambda, and we only picked the this is the this index set pick Python indexing start from 0, so it only picks this. So say so had it been want to pick the number, we'll have said 1. So but we only want to pick, so set 0. So that's why it's going to always, when it runs through the whole cabin, it's going to only pick first letter. And what it return, the value count, it returns all this U, C, B, D, E, A, F, G, and T, the number of counts that is there. So as previously seen, there's an overwhelming cabins, which this is seen here as 1014, and in the trend data set. So based on this, the best option is two groups, known and unknown. This will avoid overfitting. There's a reason for that. So on the sparse data by cabin level and function is what will be computed next. So we created a new function to classify known cabins as and the otherwise as on that won't have overfitting. So when all these are known actually, so we are going to as one. So this one is unknown, so that we won't have overfitting, just like we said, because the value relatively too high when compared to the rest of this. So and we created the function here. So we define the function is unknown cabin. The function name is unknown cabin. So we created the name. It should be used cabin. If cabin is not equal to u, then it should return 1. So I'll have 0, which means that cabin is not equals to u, then it should return 1. That means none. So that means the ones that have it. So else it should return, that is the thing that is supposed to return, which is the u as well. Equals to u. So yeah, so it returns u here, definitely. So applying we have here, so using the dot apply function and using the lambda function. So we're able to do this. Yeah. So we already have two layers, which is known and unknown here. So the siblings, spouse, and parent and children, it will make sense that these two features will combine into one. So that's exactly what I will do. It's very simple. Two features of relative and not alone. So we now said that we create a new variable which is family size. So we now said the siblings and spouse plus the data for that is the parent and children. So we just merge them together. So both the siblings, parent and children, we merge it together. So now looking at the feature engineering that we did, we want to see what we did actually. So we have all this. Yeah? So we have all this. This is what we have. And back, we changed that. We changed to look at this. We see embarked was this before, so we change it to um, 0 and 1. So something that uh, our algorithm can understand, which we did use function here. So and created last name, remember, family survival as the these are feature engineering we did. Created title as well. So family size as well. So everything that I want to carry forward to the machine learning stage looks ready. So there are some features remaining that, as previously discussed, I wish to use. So the very last step will be therefore to remove these features. So what are those features? I don't need this. I don't need, definitely I don't. So and name as well. Don't need the parent, children, siblings, and spouse. So we are dropping all of this. Just dropping it. So it will just remain as that's all. So and then we move on to the machine learning aspect. So I think on this note I will stop here. So thank you so much.
Yeah, that's good. That's great. Well done. So we'll move person learning by tomorrow. Any question, please? All your questions, please begin to ask now. And don't leave this page. Let them ask questions now so that you'll be able to explain their questions in this page. But from what I received, I've been, please explain the word lambda, lambda. I've been using lambda, lambda. Somebody asked me personally that I should try to tell you to explain the word lambda in the code. What does the lambda S stand for in the code? Are you there? Are you there? Hello? Are you there?
Okay. Okay.
Can you? Okay, so what I mean is, you know how to write, at
Your
least
voice
you
is
understand.
breaking. I can't hear you again.
Oh, I'm hearing you clearly. I think it's from your network.
Please, what Dr. Mabel Adiosun is saying is that she couldn't understand what you mean by the word lambda. And can you hear me now? Dr. Adiosun,
Yes, I can hear you. Yes, I can hear you. Yes.
instead of us simplifying the code,
Yes.
Okay.
lambda came out the same. Wherever lambda s
Yeah, fine. Yes,
Okay.
Mr. Akim Adenike, please help us to
yeah,
explain
fine.
this.
Yes. Fine.
Okay, can you hear me now?
Yes, I can hear you.
Okay, good. From the front of that lambda, I don't have it here. I will show you. What happened to that lambda from the front, from that of that S,
Okay.
is that everything coming there. Okay, let me quickly accept our tutor. Tutor, are you in?
My internet connection got tampered with.
Okay, so a question came up that why are you using the word lambda S in the front of it? You need to write lambda code in front. What is the main function of that lambda S? Explain for the part of the person that asked.
Okay, what lambda function is in Python is just it refers to just a small anonymous function. So it's not like it is an actual function or it's just like an anonymous function. When we say anonymous, that means it is there but they are not there. So and it is defined using the keyword lambda. So and lambda functions can have any number of arguments, but it's just only one expression. And they are used in situation where a simple function is needed for a short period. So just like in the case when we were using it, so we just needed it for the time being, not that we want to use it. And we define it in a standard manner using the def function. It will it will be unnecessary to use it when we are using and we want to use it and we call the def function. So we don't need to use the def function. So and the thing there is just that if we want to use it, we just call lambda and the argument and semicolon with the expression. That's just it's just the way
You
we
can display it
saw it
again.
being used in the
Tutor,
code. So
you can
just
display your code again. because
Okay.
we need to listen to you. So, questions, please. We have short time now. Questions, please. Other questions, please.
Yes,
Yes.
yes. Thank you very much.
You're welcome.
Thank you. I I have a remark to make, then I ask one or two questions. It seems there is a gap in knowledge because some of us have internet issues. We couldn't connect the first two lectures, and that's number one. And then Team R also promised to teach, give us a kind of a prerequisite class to this very class. There are some things that we still don't know. We are not on the same page yet. Then in today's lecture, you define something as LBL. I don't know. I can't remember the exact, but LBL. I don't know whether it's. You are not on that page now. I would have remember. I would have, whether encoder or something. You know,
Okay, yes,
LBL.
it's just a variable name. It's just a variable name, nothing more.
Yeah,
Just
but
you can use anything. You can use
yeah,
anything. It's not
yes,
necessarily you use that actually.
yeah,
You can use
yeah.
anything.
But I can see that you called it a name and that you use it to normalize the histogram that is skewed to the right.
Yeah, it's
Ah,
because I use it and I already called the function I want to use. It's just like saying, for example, now I can say Suraju is equals to so thing. So, but what it is not actually Suraju I'm referring to. It is that thing that I say Suraju is. I say Suraju is playful. So what we want to see, we are not seeing Suraju, we are seeing the playfulness in Suraju. So it's just a way of defining a variable. That's just variable. I think the best thing is that there is a course we did Python from scratch. Yes, I think that would be very highly recommended. So to go through all these things so we can understand them. That's the best thing. So I don't know if my Oga will, I don't know if can make that available. So if we can go through it. So that we actually explain all these lambda functions and usage and usability, we'll get to understand them there because we explain them very well there.
anyway, my question is about that you did is, so does that mean that anytime we have a skewed um, result, a histogram is skewed to the left or right, then you must have to use that function to get it normalized, or that's to prepare it for the use of machine learning?
Yes, you can. And there
Okay.
are other other use cases too. There are other ways, but this is one way. So there are other ways to do it.
Sorry, as a follow-up question to that, before she continues, if she's not finished.
Oh, okay.
The question I wrote on this thing is, why, when you're doing the bin, why 4?
Well, actually, it can be that's what I chose actually, and it depends on let me say this way because like I said, I was playing around with a lot of things. So and you can use 6, you can use 7, you can use 8, you can use anything you want to use, basically. But
Four is not compulsory.
for
You may use any
it's
amount
not
of number.
compulsory.
So you can use five
You
also.
can use any number.
Yeah,
You
the
can
bin
use
means
6.
the number of that, the number of partitions. That is the bin of bin.
So it's just partitioning. So it's not basically that it's compulsory. Not compulsory.
What it means is that out of if number is between 1,000, how do you want to partition it? Four. That four means you want to partition into four different. That means from 1 to 249, from 250 to maybe 499, from 500 to. So that's just what it means. That means how many number fall between 1 to 249 to show. How many number fall between 250 to 499 to show. That's what it means. Four there means just partition into four. If you put five, that means to partition into five. If you put seven, that means to bring it to seven
Yeah,
pieces.
yeah, yeah,
That's
yeah.
what it means.
That is clearly understood. The question is the choice of the number, the choice of the, so what possible impact? How do you come to that? Because it's an educated guess. So that is what I'm saying. But it's okay. So it's not that I don't understand that, it's why I understand. But the point is, why do I
Yeah,
have to choose four
you
instead of
can
6,
use
instead
no
of
no,
5?
it's not is my intuition. For example
Okay.
now, basically, most of the time when I do some machine learning, I build some machine learning algorithm. Sometimes, based on my experience, so I tend to follow some practices, some use cases, some ways of doing things. So you can actually find your own, and actually you can refine it. And it's not necessary after you use that for, and you can see that on the longer run the model did not perform well. You can go and increase it.
Mm.
So it's
Yeah.
not a fixed way of doing it. So that's
Yeah.
just the point, sir. I hope it is clear, sir.
Yeah, I also want to ask a question. If
Okay, sir.
um, uh, the earlier Madam made the submission on the that's the codes, the lambda, and all those things. I want to appeal to the organizer that if there is a need, if they can, you know, consider and then organize that so that we can also benefit from, because from the codes that you are mentioning and co, if we know how to do them, then we may not be asking these questions now. Because myself, I'm also looking at the codes. Yes, it's true, but we need to understand the code and how we can apply them very well, so that next time when we are doing our own thing, we don't need to be struggling. So if there is a need or they can help us, well, it will be appreciated very, very much.
Okay,
Because the course, when I see you doing it, I was like, ah, thank you.
Doctor. I will do it. Yeah, noted. And that question, because our time is will lapse now. So and I don't want to create another link again. The next 5 minutes or less than that, our time will lapse. Mr. Ayo Ajayi, Dr. Ajayi, please talk.
Uh, Good evening, sir.
Good evening to you, sir.
Thank, Thank you for the opportunity to ask my question. Please, I have a small data set I generated for my laboratory. It's about 50 rows.
Okay.
It's quite a small data set. I want to know what kind of machine learning algorithm would be most suited for to model that kind of small data set. That's my first question. My second question is it ethical or allowable in machine learning to do data augmentation? Maybe if I have a small data set like that, can I can I multiply, can I replicate it and multiply it so that it will make it bigger to use an appropriate model for it? Thank you, sir.
Okay. In a brief, we cannot decide here in absence here a type of machine learning appropriate for your data set. But from what I said last time, I said if you have target variable and you have feature variable, supervised machine learning will be most appropriate. And while using the supervised machine learning, you need to consider the target variable also. If your target variable is continuous, then there are some supervised machine learning that are approved for the continuous. That will be regression. That will be regression. And with that, you can make use of some like linear regression, ridge regression, partial regression, elastic n regression, polynomial regression, decision tree regression, random forest regression, gradient boosting regression, support vector regression, k nearest neighbor regression. I have mentioned about 10 now. And if your target variable is not continuous, maybe it is a categorical, in the sense that maybe it's a true or false, maybe it's a green, yellow, blue, maybe it's a strongly agree, disagree. All those ones, they are called categorical variables. If they are categorical, you can make use of what is called classification algorithms. Some of them are logistic regression, k-nearest neighbor, decision tree, random forest, then support vector machine, naive Bayes, neural networks, gradient boosting, Hadoop boost, and so on and so forth. But if data set doesn't contain target variable, if only what you have are feature variables, then you can go to unsupervised machine learning or thereafter reinforcement. So I will brief all this when I want to teach the course. Like I said, I will teach again for layman so that we understand it better. So you cannot decide on the type now because you don't have access to your data sets. And number two, it depends on your supervisor. If your supervisor say go and augment, then you don't have no option. But it's not ethical to augment yourself. You have to make use of what you have, make use of the available resources you have, and make the use of the available resources. Thank you.